All right, what's up, guys? Today is the first episode of the new series on how to make a 3D top-down shooter in Unity. So, we are actually going to be making this in this episode. Okay, so what we're going to need to add is, first of all, an empty game object, right? And we're just going to call this player. Okay, make sure that's set to 0, 0, and then just a little bit above your plane. And we're also going to change it to be tagged as a player as well. This is going to be for later when we're having the enemies look for the player and that kind of sort of thing. On top of that, we're also going to add a 3D object. We're going to add a sphere for now. And you can go ahead and remove this collider for now. On the actual player object, though, we're going to need a collider. I'll make it a box collider and a rigid body. All right, and on the rigid body, we're going to freeze the position, the rotation on the X and Z axis. That's just going to make it so that it doesn't kind of flip over as we move. All right, and then the last thing, we can make it a little larger. Yeah, perfect. Maybe 2. Yeah, okay. Last thing in here is we're also going to add a new material, player underscore mat, and set it to red, just so that the player is more visible for the time being. That's just an old one I had. And then I've already done it, but set your camera to 0, 30, 0, and then rotate it 90 degrees on the x-axis. That'll just make it like a kind of like a sky view or top-down view of the ball. All right. So now, next thing we're going to want to do is we're going to make some scripts. So I'll have timestamps in the description to send you to, or actually maybe in the top right, to send you to like the finished times of the scripts. So if you're a bit more advanced and you just want to see the actual finished script, then you can just skip to there and copy it down. All right. Also, if you don't know how a rigid body works, I'm not going to go into it in this video, but I do have a tutorial, and I'll link it in the top right. So on the main camera, we're going to add a script called cam movement. Mine's actually already taken, so I'm just going to make it camera underscore movement. And then on the player, we're going to add a script called player underscore movement. All right, now we're going to open those up. Reload, there you go. Perfect, okay. So now for the camera movement, we're going to want the following variables. We'll want 2 vector 3s, one called target position, and one called position to add. We're going to want a game object for the player, and then we're going to serialize the next 2 and add a range. So for this one, it's going to be 0 to 20, and it's going to be an int called cam distance. And we're also going to want to serialize the next one with a range of 0 to 5, and we're going to call it an int called movement speed, or move speed, yeah. So what these are all going to do, target position is going to be the position that we want to send the camera to relative to the player. Position to add is going to be kind of the direction that the camera needs to be moving to get towards the target position. Player is obviously going to be the player game object. Cam distance is going to determine how far away from the player we want the camera to move as the player is moving. And then move speed is how quickly we want the camera to move around, right? So now, in start, we're going to have player equals game object dot find object with tag. Make sure it's the one without the S, otherwise it's going to return an array. And then we'll say player. So this is one of the reasons why we set the player tag onto the player game object. All right. Now in update, here we're going to set the position to add. All right. So this is going to determine the direction. So position to add equals new vector 3. All right, you have to say new vector 3 because you have to create a new vector in memory, right? And this is going to be a pointer to it. So now we're going to say input.getAxis horizontal. So this will just return a number between -1 and 1, depending on what key is being pressed, either A, D, or the left arrow or right arrow by default. Left arrow and A being -1, and D and the right arrow being +1. And then we're going to multiply that by the cam distance, since it's going to be the distance between the player and the camera. And then we'll say 0 on the y-axis because we're going to set that after. And then the same thing as the vertical, or as the horizontal axis, but here we're going to say .getAxis vertical. All right, then multiply that by cam distance as well. And done. Perfect. Now, we haven't set the Y position though, and that's because we just want the Y position to actually be the camera's position. All right, so down here we're going to say target position dot Y equals transform dot position, which will return the camera's position dot Y. All right, and then before that, however, we're going to want target position equals player transform plus dot transform dot position plus position to add. So what this all does, position to add is going to be a vector 3 that represents the direction we're going. So I'll actually open this up as well. So imagine we want to go this direction. All right, this is Y and this is X. As you go up, your Y is going to be 1, right? And you're going to have to add 1 every time. So if we're trying to go up, we're going to be pressing down on the W key, which is going to be adding 1 to position to add. So our position to add would be 0, 0, 1, because we're just going up on the Z axis in this case. All right, sorry, this is Z, not Y. If we want to go this way, our position to add would be 1, 0, 0, because we're going to the side, but only on the X axis. Now if we want to go this direction, it would be 1, 0, 0, 1, because we're both going up and to the right. All right, hope that makes sense. And then it's all just negative if you're going this direction or that direction. Now, here what we're doing is we're taking the player transform.position, so this position here, and we're adding the position to add. So that'll turn the target position into either here, 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 or here. All right. And then we're going to set the Y position to the camera Y position so that it doesn't go down and follow the player on the Y axis as well. Cool. So then after that, we're going to actually move the camera. So we're going to say if target position dot X is not equal to transform dot position X. So if the camera is not already in the right position on the X axis, we're going to say game object dot transform dot position plus equals, again, a new vector 3. And then here we're just going to say target position dot X minus transform position dot X times time dot delta time, so that we normalize it a bit depending on different computers, and then move speed, multiply that in as well, and then 0, 0, 0. Cool. And then close that, and then we're going to do the exact same thing for the Z axis. Target position dot X, or dot Z, sorry, not equal transform dot position Z. Game object dot transform because it was the wrong game object. Game object dot transform dot position plus equals new vector 3 0 0 target position dot z minus transform dot position dot z times time dot delta time times move speed. All right, so what does this all do? Oh, what's that in here? We have to put another comma. Yeah. All right, so what is this actually doing? Like, why are we subtracting target position and transform position? So if we look again in here, and let's say, again, we want to go forward like this, all right? How do we actually, like, what do we add to this to go up? Well, you'd say 1, 0, right? But how do you know, like, from this position here, how do you know what to add? So let's say that this is 0, 1, and this is, oh, that was awful, and this is 0, 0. Now, you might say, oh, just take this and subtract this, but then that would give you -1, and that would send you backwards. So you have to take this vector 3 and subtract it by this vector 3, and that'll give you 1. And then if you want to go the opposite direction, the target position would be down here. This would be 0, -1, and this would again be 0, 0, right? So you would subtract this position by the player position, and it would give you -1. And the same as if this was 1, or this was -1, and this was -2, it would be the same position. It would be -2 minus -1, which would be -2 plus 1, so -1. Hopefully that made sense. So then that is actually all for the camera movement. So we can close that for now and then go down here to the camera. Oh, as it loads. Now I don't actually remember exactly how it was, but I think it was roughly 10.3 that was working for me before. Yeah, so you can see the player is not moving yet, so obviously it's going to just stay relative to 0, 0. But you can see the player would kind of be just off in the back as you're moving forward. You can also change it so that's like a bit closer if you want it to be a little bit less, I don't know, extreme. And in this case, you could probably speed it up a little bit as well, just to make sure it actually gets there. Yeah, cool. I'm going to leave it at 10.3 because I like it like that. But then now we're going to actually add the player movement. So we're going to open that up. And here, our variables that we're going to need are our rigid body, called RB, and then a serialized integer with a range of 0 to 20. And yeah, so an int called movement speed. So if you don't know what a serialized field is, it just means that you can keep your variable private while still seeing it in the inspector, like over here. So that just makes sure that it won't be accessible by other scripts, but you'll still be able to see it in the actual Unity game engine. So here in start, we're going to have to set the rigid body. So we're going to say RB equals get component rigid body, and that'll just return the rigid body attached to the game object that the script is on. And then the movement is very, very simple. I'm going to say float vertical movement equals input.getAxis. Again, this is how we're going to be doing most of the movement. The vertical axis times movement speed. And then, yeah, we don't have to multiply this by time.delta time because we're going to use velocity, which is already kind of normalized with time. And then float horizontal speed or movement. And this is the exact same thing as the top. Dot get axis horizontal times movement speed. All right, and then all you have to add next is rb.velocity. So we're going to change the velocity directly since there's not going to be any knockback in this game. We don't have to do it by force. Equals new vector 3 horizontal movement rb.velocity.y. So we're just going to keep the velocity that was already there, and vertical movement. And that is all for the programming part of it. So we're going to go back, and we can set the player speed to around 10. And there you go. He's moving around. The camera's going right ahead of him, so you can see what's going on. And when you stop, the camera goes right back onto the object because the target position is being set to the player object plus the input. But if there's no input, it's just being set to the player object. So that's all we got for today. In the next one, I'll probably add the shooting, or I'll add some enemies or something like that. All right, I hope that this was helpful. I hope you enjoyed. If you did, leave a like, subscribe if you want. If there was something that was a bit confusing for you in the video, feel free to leave a comment. I'll be answering every single one of them whenever I end up getting a comment. And yeah, again, I hope I was helpful, and have a nice day. Cheers.